Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. I have Niles Eldredge. We're going to be talking about biological theory, parallel causation in oncogenic and anthropogenic degradation and extinction. And we'll get into what that means. But Niles, thanks for coming. How are you doing?
Oh, my pleasure. I'm doing very well, thanks.
Oh, good. Tell me a little bit about yourself and tell the listeners.
Well, I'm an evolutionary biologist. I spent my entire career a paleontologist at the American Museum of Natural History in New York. That was a good job, and I kept it for many, many years. I'm now retired. But I've been interested in evolution and what the fossil record can teach us about it. I think the most important thing I did in my early years was a paper with Stephen J. Gould called Punctuated Equilibria, an alternative to phyletic gradualism, meaning that evolution just occurs basically when it occurs rather abruptly, rather rapidly, and then is usually followed by long periods of stability and not much, if any, evolutionary change is discernible. And we were both students at the American Museum, and our mentor was Norman D. Newell, who was a famous guy. And when we were kids there in the 60s and Steve went up to Harvard in 1967. But when we were being trained, we were a little frustrated with our teachers' preoccupation with extinction and not evolution so much. And it took us about into the 80s before we realized that there is really not very much evolution unless and until you reset the clock. You turn over the systems of the world, you have extinction events. Some of them are huge. They envelop the entire world's biota. Famous ones like the end of the Cretaceous when the terrestrial dinosaurs went extinct and that kind of thing, and right down to smaller scale episodes of extinction. So without extinction, you don't tend to see evolution is like a rebound, very often a rebound from an extinction event. So we were into that.
Why? Quick question here. Why do you think that evolution doesn't seem to happen very much at all unless there's a major...
It's an excellent question. Things tend not to change because if it's working, you don't mess with it, basically, I think in common parlance. Most species are spread out into a variety of different ecosystems facing different challenges for life. So there's no one single direction of evolutionary change that you're likely to get. In fact, if you get climate change, natural climate change of the past, what you tended to see was species moving around. If it got warmer, species would start moving north, and I'm including plants as well as animals, because plants move by dispersing their seeds. So the recipe is there for stability. It might even be built into some degree into the developmental process as well. So anyway, stability is the name of the game. It's not just change, which was sort of the picture that had come down to us from Charles Darwin.
Okay, continuing on with your background, please go ahead.
Oh, okay. So I got in the 80s. I had small children by that time, and I was getting alarmed at what was happening in the environment, the modern environment, because basically I was studying things that were 380 million years old and long extinct. But I realized that there were a lot of warning signs, and I was hearing the cries from the earlier environmentalists, Rachel Carson and so forth, pointing out the possibility that we were beginning to drive many, many species extinct, as if we were causing an extinction event on our own. Most of the extinction events in the past happened through things like volcanic eruptions and collisions with objects coming in from outer space and that kind of thing. So physical causes, not human causes. Humans are relatively recent on the planet anyway. But it looked like we were beginning to do the sort of thing that those meteorites did at the end of the Cretaceous that drove the dinosaurs extinct. So I started looking harder at the biology of extinction events. We did the Hall of Human that's the human biology hall. No, we did a hall at the American Museum of Natural History, the Hall of Biodiversity, which was the first issues hall that the museum ever did. That was in the mid-90s, late 90s, I think 97 or 98 that it opened.
What do you mean the first issue? You mean the issue of the loss of biodiversity?
Showing nature the way it is. What's going on with nature is we're losing so many species around us. We wanted to point that out. So we have a wall of life there, and we also examine the world's ecosystems through other media. The wall of life is a bunch of specimens on a wall. It's kind of spectacular, showing basically the genetic diversity of living systems. But the game of life is played out in a different context. It's played out in ecosystems. So we had the wall of life faces the big diorama of an African rainforest and so forth. And then with other media, we treated the ecosystems of the world. And the point is that we wanted to show, though, that these ecosystems are imperiled, and therefore the things that are in those ecosystems, the species that are in those ecosystems, are facing increasing threats, and we're losing, I think we thought back then, even, 35,000, 40,000 species a year. I think that was the estimate. Back in the 90s, it's very hard to judge, but we were blowing the whistle on that and trying to inform the public. So in other words, we weren't painting nature pristine. We were painting a picture of what nature used to be like, but what's going on with it now. Its disruption and its degradation and the threats to all species of the world.
What was the public reaction like when you first brought this up in the 80s, and how has it changed over time, or has it?
I think there was a growing awareness. We were sounding an early alarm, not the earliest one. There was another exhibit like this in France, and TV started covering it. And as I say, there were environmentalists going back into the mid-20th century who were pointing it out. In fact, one of Darwin's contemporaries in 1831 said that human beings are going to end up really messing with the planet really badly, and this was going to be bad for all the other living species of the world. So this has been out there, but it's a growing realization. And I think now with climate change, which was being discussed when we did this hall, but it wasn't by any means the horrible threat that it's become. Nobody, certainly us, but nobody else, I think, really saw how fast that was going to mushroom and pose a horrible problem to life on Earth, including our own human life, as we know. So I think now the public in general is quite well informed about the dangers that we're facing and are about to overcome us. So yeah, it's been growing. But I think our hall helped a little bit in the 90s, yeah.
So what's your, after all these years of working in evolutionary biology and seeing extinctions, et cetera, the fossil record, what do you think is going to be where are we headed in the near term, maybe the next 100 or so years, and then maybe long term? What are your thoughts?
Yeah, it's one of the reasons why I wrote this paper with a cancer biologist, because it turns out they're very similar problems. And I think that if we don't take care, it's like these are the twin scourges. One's inside us and one's outside us, but we're causing it. And if we don't sort of look at both systems and understand how we can not eradicate them, I think that's too far too late for all of that. But I think try to make them as view them both as treatable ecological evolutionary diseases and stabilize things. I think we have a shot at it. I'm not a climate scientist, so I don't know for sure, but I'm scared myself by the sort of the tipping points that they're talking about, how many degrees centigrade we can raise the temperature on this Earth and expect to be able to survive. I'm not talking necessarily about the extinction of the entire human species, the 7 billion of us, but of the quality of life, all of the great things that we've managed to achieve, including the internet and the ability for you and me to talk as we were doing today. These kinds of things we shouldn't take for granted. I think they're under threat. So basically the human quality of life. And just as cancer, I think we have in the paper that 40% of the people living in the world, in industrialized nations anyway, will probably contract cancer at some point in their life, usually in older age. And of those, about half of those will die of it. So the idea there is to try to stabilize now. It can't be eradicated, too many different kinds of cancer, too many different basic subsets of causes of it. But it can be treated as an evolutionary ecological disease, much as what I'm saying we should be doing with our planet as a whole, and stabilize things, treat it as a chronic disease. I mean, the bottom line here, basically, what happened in cancer, the reason why we compared them, the flag was up when my colleague, James DeGregory, published a book a couple of years ago, 1918, called Adaptive Oncogenesis, and seeing cancer as the evolutionary process as it is. And that's in that book, I learned for the first time that when a cancer gets going, if it's going to succeed, what it typically does is to basically arrange for its own life support system. It's a process called angiogenesis. It can trigger the formation of blood vessels and bring nutrients to the site. So basically, a cancer, a baby cancer tumor, quits its job as a liver cell or what have you, and functioning along with its other similar cells in an environment with other kinds of cells to make a nice harmonious working organism. It quits the job and it gets its own source of food and is able to just happily sit there and multiply like crazy and not do any work, and meanwhile threaten and degrade the environment around it. And when I read that, I said, well, I know what that is, because this is what happened to us. I figured this out starting in the 90s, and we have this in the paper as the parallel causation. When we invented agriculture, we took life into our own hands. Prior to the invention of agriculture, it's known especially from the Middle East, but there were other places like India, in the New World, and in Africa, there were other sites where agriculture was invented more or less at the same time, about 10,000 years ago. That took us out from basically the standard way that organisms make a living, which is they are parts of little groups of their own species that are integrated into local ecosystems. And their numbers are limited by the amount of resources that they're adapted to feed on, that they can extract from the environment in which they're living. So, for example, when people who were pre-agricultural peoples were first contacted by Western world people, so we have some record of how they were living, and there's still some people that sort of still live this way. They're living in bands of 40, no more than 70 people, in forests, out in deserts and so forth, living a life that's limited by what they can grab, what they can get, what they can hunt, what they can successfully harvest from naturally occurring plants. And that is it. And there's a limit on how many babies you can make that will survive in a situation like that. It's the carrying capacity of the environment. I'm looking out my window right now. Yeah, go ahead.
Yeah, all right. So in the development of people, what were watershed moments that really accelerated or made it, unsustainable? There must have been many, and what are some of those?
Yeah, well, things took off sort of slowly and then logarithmically increased. Another resemblance between this situation and the natural world that we're causing and cancer is it tends to spread. And there's really kind of fun maps of looking at where, for example, from the Middle East about 10,000 years ago, the progress of the spread of agriculture up into Asia, Eurasia, and Europe, we're talking about, is very instructive. And everything has been accelerating. I think we even know this in our own lifetimes. I mean, I'm 75 years old, so I've seen an awful lot of change. When I was a kid, cars had only been in for 50 and things like that. Now we've got computers and whatnot, and the technological advances that we're making. It's a technology evolves. That's the evolutionary component of this scenario. And it's just evolving more and more quickly. So an inflection point to do that, industrial revolution after the agricultural revolution. So a couple of 100 years, but it's just astonishing what's going on in my own lifetime. And the population has doubled at least since I was a kid. I was born in the 1940s. It's 7.2 or 7.5 billion right now. It's just doubling more and more quickly. So it's just amazing. One one interesting sort of a glimmer, an insight into the fact that it really is still a matter of overpopulation. is the one-to-one correlation, the correlation mathematically of over 99% with the numbers of people that have been added to the Earth, growing human population on the one hand, and the growing amount of carbon dioxide in the atmosphere. And I think probably the very first paper about that came out of our department with this same man, Norman Newell, who was our mentor earlier on, working with a statistician, Les Marcus, and they established that. Now, if you just Google the number of people estimated to be on the Earth right now, with the rate of increase of carbon dioxide, just Google that. People are constantly publishing on that. It's still way over 99%, which is proof, to my mind, that global climate change is still rooted in the raw numbers of how many people are on the Earth. What I'm saying about these graphs, do you want to know how many people are on the Earth? You look at the CO2 in the atmosphere, not just locally, but you get the data from around the world. And vice versa. If you want to know how much carbon dioxide is in the atmosphere, you take the latest estimate of the number of people on the Earth. Same thing. So it works both ways, in other words, because the correlation is so tight. And it's just an experiment.
What about resiliencies of our planet and our ecosystems? Are there any? Are they just being overcome? Any thoughts there?
I remember telling my co-author, we had been writing back and forth since 2010, but it wasn't until his book came out 2018. And I said, next time, he flies all over the place giving lectures. He's still very much in the game. He's in Colorado. I said, next time you fly back to Denver from Chicago, look out the window of your airplane. You look down, and the Midwest, the breadbasket of the United States, you look down and it all looks all green and nice and everything. That is all disturbed tissue. That is a not pristine environment. Most of the things that ought to be living there can't live there anymore. They don't live there anymore because we've changed the environment. So it's great for us. So the answer to your question, yes, some people have estimated that we could feed as many as 50 billion people on the Earth, but it would wreck the planet. It's wrecking our planet right now. So the trick is to see that the more food you provide, the more people there will be. The more people there will be, the worse our problems will be. We can't just live alone. We could see that with the climate change. We need the rest of the ecosystem services to regulate the climate, the distribution of waters on the planet, and so forth and so on. We cannot just say, all right, everything can die and we can live alone into big, tall skyscrapers and so forth. I really sincerely doubt that. Of course, none of us living now could even imagine doing that or would even want to do that. But on the other hand, that would be a scenario. But I think it's probably in the long run, or maybe even the short term, impossible to expect us to be able to survive. But if we just
if you live in a city or some kind of planned community, it's kind of like that already. You know, people are like really the predominant living thing, except for some pets. That's it.
I mean, cities are. I paint these dreadful pictures, and yes, cities are really awful for the biodiversity of the world. On the other hand, that's where a tremendous amount of the wealth and knowledge and political clout and so forth is in cities. That's the good side of cities. And so I think the cities do resonate in a positive way with the rest of the natural world. But if we make one huge city, like what they call a corridor from Boston all the way down through Washington, it's probably even more extensive than that now. That is almost a single long city. If we just cover our entire continent, North America, with those kinds of structures, I really think that would be a bridge too far. We would be destroying weather patterns even worse, and distribution of waters and so on and so forth. So, yeah, we could do it, but we at the cost of our fellow citizens of the planet in ecosystems in which we were born. But I think it's more than just of an aesthetic or an emotional concern. I think it's a real practical concern. I really don't think this planet functions very well without its rind of life on it that's there. That includes far more than just us.
Well, so the world population, for instance, is growing, but it is percentage-wise slowing. It seems like we may hit an equilibrium, in the next 20 or 30 years. Again, what do you project out? I mean, with your paper, it calls an alarm, but what's the recommendations?
Well, first of all, I'd like to point to we think we're discovering things, but the people who preceded us pretty much knew about this. There's a really good book called How Many People Can the Earth Support by Joel Cohen. He wrote that in the 90s. I haven't seen anything that's better. And he has a little historical section. The guy who invented the microscope, von Leeuwenhoek, I believe it was Dutch, he was interested in this problem. And I think he estimated that it would level off, reach an equilibrium, human population, at around 13 billion, which is an interesting figure. And other people have come up with numbers sort of like that. One problem with that, as I've already mentioned, is that people are now saying, "Wow, we can actually have 50 billion because we have the technology that we can feed everybody." Which I think, the more food you make, the more people you will make, and that's an endless cycle, and that'll go on and on. No, I actually think there's a better chance with cancer in curbing that and treating it as an ecological disease and a chronic disease, basically. Rather than trying to nuke it, but keep it in equilibrium. It's the new sort of evolutionary-based approach that I learned about from James's book. I think the reduction of human population is necessary for our continued survival, but I think it's a much bigger problem. Famine, warfare, and disease haven't done it yet. I mean, if you look at the curve of human population growth, we have this in that Hall of Biodiversity at the American Museum. If you look at that, and you look at what the Black Death did in Europe, whenever it was in the 1300s or so, it basically cuts the population in Europe way back. So therefore, at that time, even the global population way back. But it only took a generation for it to get right back on track. So disease won't do it. Warfare won't do it. There are unequal ways to do it. I don't know how to. It has to come from the top. It has to be. It's like we have to. The only hope, as I say, I'm pessimistic about the cooperation necessary, would be adding population concerns directly and plans to the Paris Accords or something like that. So there could be international agreement on how we best curb the human population numbers. I mean, what Joel...
Yeah, that'll be a very tough subject. What are some recommendations you've seen that are...
It's almost impossible. We're not good at looking into the future. We're very selfish people. We are communally interested in each other, and we do help each other. But we don't have that on an international basis, as we all know. I mean, there's fights and so on. It's I don't know.
Is there such a thing as a reasonable recommendation that people would maybe actually follow, or no?
Well, it would have to be prorated. Like the carbon footprint of somebody who's living in the United States, like we are, talking on computers, is what? Is it 7 times greater than somebody who's tilling a plot of land in some underdeveloped country elsewhere in the world? So, there's more of them than there are of us. But our negative effects on the environment are, 7 or 8 times worse than theirs are. So it's got to be prorated in an equal sort of way. I'm concerned about, we've lost at least 500 languages, I think, maybe more now, since the 19th century. I'm worried about losing cultural diversity as much as I'm worried about losing actual physical diversity of human beings or anything else. So it would have to be, I don't know, it's a problem. It would take a Solomon far greater than me to figure out how to go about doing that. But it has to be regulated. We have to regulate it. I started to mention that Joel Cohen, if you follow him, he finally answers the question to his book near the end. He says, how many people can the Earth support? Depends on what you mean by support. He says, yeah, but if you mean the level of existence of a middle-class American citizen, then he comes up with, if you read between his lines, maybe 2 to 4 billion, and already we have almost to that on the planet. So
are there any voices that seem to have good ideas out there that you've interacted with?
Beyond what I've just said, I haven't seen it. I mean, China tried to limit the Han people, the dominant people in China, to one child per family. What am I saying? And that met with a lot of resistance. I don't know where that's at now. Maybe they decided economists want to see more people. It's good for the economy. Older people want to see more people because who's going to pay for Social Security if we don't have more people coming up? So there tend to be built-in arguments naturally arising within populations saying doing this would be bad for us in the short term. I don't know. I don't know what to say. It's going to have to be international agreement, and that kind of thing is pie in the sky right now, given the nature of the world as we're in it right now, as we reach bursting point or saturation point in our populations, and nobody's getting along with anyone, particularly very well.
Do you feel like there's lessons that you learned from being, an evolutionary biologist beyond what you've spoken about? Is there going to be a great adaptation or extinction coming?
Everything goes extinct. You don't get sort of a rebuilding and more evolution, but a rebuilding of living systems until whatever's causing the extinction event dissipates, goes away, becomes extinct itself. So in other words, it took 10 million years after the major mass extinction events for the life to get up, chugging along with slightly new players as the ecological wheel got reinvented through evolution. Dinosaurs go, so the mammals had a chance to blossom forth and take those jobs, if you will, in the ecosystems. But it took 8 to 10 million years for that to really happen. And that's the natural sort of the way it goes. But we are the vector of the extinction right now, and I don't think nobody wants us to go extinct. I don't want us to go extinct, because I think for all the bad things that we're doing to the planet, there's all these amazing good things. We're the only species that is sentient, that's basically, in a sense, aware that it's alive, can look out the window and see the world out there and think about it and cogitate on it, because no other species that we've ever heard of or ever observed can rationally be thought to be as self-consciously aware of being alive as we are. And that's a gift. And we've done marvelous things with that gift in our arts and sciences and growth of knowledge in general, and all the wonderful things that human beings can do. I think it would be a crime against, the natural state of things for us to basically commit ecocide on ourselves. It would win a Darwin Award for stupidity. On the other hand, I don't see us seeing what even the short-term, long-term would be and acting upon it in a rational way. We have that capacity, but I'm not hopeful that we'll be able to do it. That's what I'm saying. And I wish I could be more hopeful. I was more hopeful when I wrote about this stuff starting in the late 80s and 90s, and with my little kids and all their friends and everything, I tried to give a message of hope. And it's going to take concerted action. I think people are smart. I do think it's going to take differences in social structure. It's going to have to involve a worldwide agreement. As I keep saying, I don't see that in the offing, but I hope so. I mean, I'm old. I'll be gone before this thing plays out. But I got kids. I got grandkids. And they got friends, and I think this is a magnificent world in many respects, and the human experience deserves to be coddled and kept going. It needs to be shared more broadly amongst us all. We all have something to contribute around the whole world. But
very good. Well, now we're just about out of time. What's the best way for people to read your recent work and maybe some of your older works and find out more?
But we can go to my website, nileseldredge.com, and see that. I'm on the internet. They can Google me. This cancer paper is sort of technical. It's in biological theory. It's with James DeGregory. It came out a couple of months ago, but it's free. It's freely downloadable from a journal called Biological Theory. Famous paper was way back in the 70s on Punctuated Equilibria. That's available online. I do have a blog with Bruce Lieberman. I don't have the address in front of me. And I have a YouTube channel under my name, which has some of these things discussed and some film bits.
Okay. Well, very good. Well, Niles, I appreciate you coming on the podcast. Thank you.
Well, thank you. I enjoyed it.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.